Hey guys, since I'll be gone today, we're going to try to get some notes in and be able to move on with trying to do it this way. So we'll see how it works. All right, so you guys, I'll give you guys these notes. You guys should have these notes through Google Classroom, so you should be able to follow along with me. This first one we're going to do is it says to solve the system using a graphing calculator. So this is something that we saw last chapter. We saw if I look at these equations right here, I know that they are both linear. Now, why are they both linear? Well, I don't have any x squared. They're all x to the first power and y. So that tells me that this is going to be a linear equation. Before, when we had something like this, we would solve this using either substitution or elimination. So for example, we would multiply the top by -2, and that would end up canceling. We get -2x plus 8y equals -18. And then we'd be able to add all of those together. We would solve it that way. Now let's remind ourselves, they want us to solve it using a graphing calculator, and I want to do that too, so that we remember what we're looking for. We're not just doing some math, we're actually looking for the solution to those two equations. And the solution to those two equations, if you guys can remember, is the place in which, if you can see my mouse, there it is. See my mouse, it's right there where they intersect. If there is a solution, it's where they intersect. If there is no solution, which means that they're parallel, that means they never cross, or they could end up being the same line. Those are our three options that we learned about. This is what we call solving linear equations. Okay, so now what we're doing is we've moved on to quadratic equations. So now what we're going to do, we're going to talk about today, is we're going to talk about solving quadratic equations. But before we move on to that, what I want you guys to do is I want you guys to pause this, and I want you to find, well, let's go back. This equation here, we're going to look at what's the solution to this graph. The solution is the point at which they cross. So I'll come over here to my graph, and I'm going to approximate because it's not going to be exact. I'm going to click right there, and I see that my solution to this graph is the point 3.4, -1.4. So the solution is going to be an ordered pair. So the solution right here is negative, the x is -3.4, no, it's positive 3.4, and the x, or the y value is going to be a -1.4. Okay, so that would be our solution. Now what I want you to do is I want you to pause. I want you guys to go into Desmos, and I want you to graph these in Desmos, and then I want you to find the solution, the ordered pair, in which these two where they intersect. So go ahead and pause and do that now. All right, now we're going to move on, and our goal for the day, if you guys can see up on the board, is to solve nonlinear systems of equations. So these are what we call linear systems of equations because they all have x to the first power. Now we're going to move on to nonlinear. So here we go. How can we solve a nonlinear system of equations? So let's look at some nonlinear systems of equations that we have here. Now, up above, they give us 6 systems of equations. And down below, they've got the graphs of each one of those. So like, for example, in A, they give me x squared, which I know that's quadratic. So since it's quadratic, it's going to give me a parabola. And y equals x plus 2, that's going to give me a line. It's going to be linear because it's got x to the first power, so the biggest exponent there. Now I'm going to look where in my graph is there going to be I'm looking for the graph A, B, C, D, E, or F that matches up with these two equations. So I know x squared. That is what we call our parent function, if you remember. So our parent function always has to go through the origin. So I look through my graphs. I see, oh, this one goes through the, A goes through the origin. I look at B, B doesn't go through the origin. C doesn't go through the origin. D doesn't go through the origin. E doesn't go through the origin. And F doesn't go through the origin. So that tells me right away by process of elimination that A and A go together. That means that the solution So this set of equations are going to be the 2 points at which the graph intersects. Okay, now what I want you to do is, again, I want you to pause, and I want you to go through, and you can use Desmos, or first of all, I'd like you to try using process of elimination, knowing what you know about these graphs, to go ahead and find. So in this case here, we've got an x squared, so we've got a parabola, and we've got a line. So we've got to go through, and we've got to find one that's a parabola and a line. Well, right away, that eliminates B, C, and D, because they're both parabolas, so we know that B has to be either E or it has to be F. Okay, now look at the slope. Remember, the linear line, we've got a slope. Is it a positive slope? Is it a negative slope? Is our line going to be rising? Is our line going to be falling? Use that as a process of elimination. Okay, if you can't figure it out, I would like you guys to go onto Desmos and try to figure it out. Work with the partner. So pause it again and work with the partner and see if you can come up with the solution or come up with the graphs that go with each one of these equations here. All right, so now that you've done that, kind of familiarize ourselves with the lines again and graphs, and let's move on and let's look at more. We're going to look at a graphical way, and we're actually going to solve it. So not only are we just going to look at it, we're going to solve it. So we've got these two equations, and we're going to solve it by graphing. Now, graphing is not a great way to solve. The purpose of graphing is, again, is for the concept. Okay, the concept of graphing is we are looking for where the graph, the two graphs, the two equations intersect. Okay, we're looking for where they intersect. And remember that where they intersect is going to be a point. It's going to be an x and a y value. Now, before with linear, we only had there was either one solution, there were no solution, or infinitely many. If we remember, if we look back at the beginning over here, okay, we're looking for where they intersect. How many times could they intersect? Well, they could intersect at 2 spots. Like if we look at A, they've got an intersection here, we've got an intersection here. So because they intersect at those 2 spots, we know that there's going to be 2 solutions for those 2 equations. C, we look at where they intersect, they're only going to intersect at 1 spot. I look over here at D, they intersect at 2 spots. I see F intersects at 2 spots. So all these have intersections at 2 spots. Another option could be, if I had a graph, I could have an equation, a quadratic equation that did that. Could have another quadratic equation that did this. How many solutions would there be there? Okay, I looked. Is there anywhere that these 2 graphs intersect with each other? Nope. So this would be a case of no solution. But we will try to look at some of those later. For now, we're going to be working with ones that actually work. So let's look over here. We're going to do it graphically. We're going to look at the concept. We're going to remind ourselves that we're looking for a point. So I'm going to go ahead and I'm going to start by graphing this one up above. It's quadratic. So remember, the first thing that we need to find when we go to graph it is our vertex. It's in standard form, so negative b over 2a. So I get positive 2 over 2 times 1, so the x value of my vertex is 1. I go back up, I plug it in, 1 squared is 1, minus 2 is negative 1, minus 1 is negative 2. Okay, so now let's make ourselves a t-chart. X, y, I've got positive 1 on the x side, I've got negative 2 on the other side. Let's put it over here on my graph. Positive 1, negative 2, put it down. Okay, now I'm going to draw my axis of symmetry. And I'm going to pick 2 more points. So I'm going to go with, let's go with 2 and 3. So 2 squared is 4. 4 minus 4, 0, minus 1 is negative 1. And then 3 squared is 9. 3 times 2 is 6. So I have 9 minus 6 gives me negative 3. Minus 1 gives me negative 4. Oh, nope, that was wrong. 9 minus 6 gives me positive 3. Minus 1 gives me positive 2. There, that looks better. Okay, so I come over here. I've got 1, negative 2. I got 2, negative 1. And I can reflect that point across. And then 2, 2. And I can reflect that across as well. And I end up with point over here. Okay, so that gives me a pretty good idea of what my graph is going to look like. Show that it goes on and on forever. And now what we're going to do is we're going to graph this one right here. Now remember, this is not x squared, so this is going to be linear. Okay, linear, remember the form of linear is y equals mx plus b, where b is our y-intercept and m represents our slope. Okay, so my y-intercept in this case is negative 1, so I come down to negative 1, and my slope is negative 2. So I'm going to go down 2 over 1, put a dot. And then I go down 2 over 1, and then I go up 2 over 1, and I go up 2 over 1. Gotta make sure that my line is falling. Let's see if I can draw a straight line here. Okay, here's my graph. Now remember, my different cases for my solutions. I could have one solution. I could have two solutions. Or I could have 0 solutions. I suppose I could also have infinitely many solutions, but in that case, it would be where both of my equations are the exact same line. So let's look at which one of these options happens. Well, I look for, remember, I'm looking for where does the graph intersect. I come up here and I look. Oh, it looks like I potentially only have one solution on this case. Okay, the reason I only have one solution is because it looks like the graph only potentially intersects at one spot. This one spot ends up being 0, an x value of 0, and a y value of negative 1. Okay, so that looks like my solution would be 0, negative 1. Now, just my graphing isn't very accurate. We've got human error here. But what we got to do is I want to check this answer. I want to see that it works. So I'm going to go back over here to my two equations, and I'm going to remind myself that 0, negative 1 was what looked like my solution. So what I'm going to do is I'm going to plug this x value, and I'm going to plug this y value into both of these equations up above. So for the first one, I'm going to end up with negative 1, plugged in negative 1 in for y, plus 0 squared minus 2 times 0 minus 1. Oh, minus 4, minus 1. So I end up with this first equation. I get negative 1 equals 0 minus 0 minus 1. So does negative 1 equal negative 1? Yes, in fact it does. So that works. That works in my first equation. Now I'm going to verify it in my second equation to make sure that it works. So I'm going to plug in negative 1 for y equals negative 2 times 0 or minus 1. So I get negative 1 equals 0 minus 1, which is negative 1. You betcha. This one works. I just verified that my solutions worked just because I have human error up here. So if I were to solve by graphing, that's what I would do. Graph both equations. We look for where the graphs intersect. Okay, now what we're going to do is I'm going to show you two more methods really quickly. I'll show you one that's more of my favorite, and then I'll show you another one that I'll just introduce it to you so you guys can see it. So what we're going to do is we're going to solve by substitution. The first thing that I'm going to do is I'm going to get y by itself. Okay, so we got to get y by itself. So let's just rewrite both of these equations. This first equation would be y equals, I just added the y over to the other side, and then I added 1 to both sides as well. Okay, hopefully we're okay with that by now. So I didn't move the x squared anywhere, so I get x squared plus x plus 1. Okay, that's what it would be rewritten. Okay, now my second equation, I'm going to subtract the x over, so y equals negative x plus 4. Now, what we're doing is, remember, we're looking for where they intersect. So essentially what we're doing is we're looking for where are their points the same. So what we can do is we can go ahead and we can set, what I'm going to do is I'm going to substitute in for y, I'm going to substitute negative x plus 4. So this negative x plus 4 is going to go up and it's going to replace y, because y equals negative x plus 4. So I'm just going to replace them. So I get negative x plus 4 equals x squared plus x plus 1. All right, now I got rid of my y. So what I'm going to do is I see that I've got an x squared, so I can't just get a single x. I've got multiple x's. So I'm going to combine like terms. I'm going to get everything on the same side of the equation. So I'm going to add x. I'm going to subtract 4, so I get 0 equals x squared plus 2x minus 3. Okay, because I also had to add x to this side. I also had to subtract 4. So everything canceled on the left, and I'm left with this on the right. Okay, now, oh, look at this. This is a quadratic equation, which means that I could probably use one of my 5 methods to go ahead and solve it. So the first thing I'm going to check for is this factorable. So factors of negative 3, they add up to be 2. Okay, so I see, oh, since it's a negative 3, one has to be positive, one has to be negative. I'm going to go with 3, negative 1, you betcha, it is factorable. So I get 0 equals x plus 3, x minus 1, and then we know since it's equal to 0, I can go ahead and separate these two. X plus 3 equals 0, and x minus 1 equals 0. So I get x equals negative 3, and x equals positive 1. So that tells me I have 2 x values. Okay, this is not my ordered pair. These are my 2 x values. So that means I have an ordered pair. This one's going to have 2 solutions. So I've got negative 3, comma, I don't know what my y value is for that point, and I've got another ordered pair where I've got an x value of 1, but I don't know my other y value. So what I've got to do is I've got to take these 2 x values and I'm going to plug them in to one of my equations up here. Well, okay, I don't know about you guys, but squaring something, there's a lot that goes on with the quadratic equation. The linear one looks like it's going to be the easier one to plug in for. So what I'm going to do, because we're solving for it, it doesn't matter which equation I use, I'm going to go ahead and I'm going to plug in what I found into x plus y equals 4. So I plug in, I'm going to start with the negative 3. So I plug in negative 3 for x plus y equals 4. Add 3 to both sides, y equals 7. So my ordered pair, one of my solutions, is negative 3, comma 7. If I go to the ordered pair, that's exactly where these two graphs are going to intersect. Okay, then I look at 1. Now I'm going to plug in 1 for x. 1 plus y equals 4. So that tells me that y equals 3. So this ordered pair is going to be 1, comma 3. So my two solutions to these equations, the two places that they intersect, are going to be negative 3, comma 7, and they're also going to intersect at the point 1, comma 3. Okay, so that was by using substitution. Okay, that was easy because we got y all by itself, and then we were able to factor it, or use one of our tools that we have to go ahead and solve. So let's look at one more method, and this one's elimination. Okay, this one is, if you guys remember elimination from algebra, or from the previous chapters that we talked about, it's going to be the same type of deal, okay, where I've got negative y, positive, or I'm going to try to get rid of one of these variables. Well, if I look over here, when we're working with linear equations like this, I probably want to go ahead and get rid of y, because I know how to work with x squared and x. We worked with that quite a bit the last chapter. So I'm going to go ahead and I'm going to cancel negative y and positive y, because we're going to elimination. Remember, we add them together. So I end up with 3x squared. Add these together, so minus 3x, and then these cancel out, so it's 0, and then negative 2 plus 0 gives me negative 2. So I end up with 3x squared minus 3x equals negative 2. Now, can I go ahead and solve this? Not yet. Remember, we've got to get it equal to 0. So 3x squared minus 3x plus 2 equals 0. All right, now I've got a quadratic equation. Let's check. Can I go ahead and factor this? So 3 times 2 gives me 6, positive 6. Are there any factors of 6 that add up to be negative 3? So 1 and 6, 2 and 3. No. Okay, so I think I'm going to go ahead and I'm going to use my quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so here we go. I've got 3 for, I'm going to, negative 3 is my b, so positive 3 plus or minus 9 minus 4 times 3 times 2 all over 2 times 3, which is 6. So let's simplify this a little bit. 3 plus or minus the square root of 9 minus 4 times 3 times 2, that's 12, 24. So 9 minus 24 gives me negative 15 all over 6. So 3 plus or minus, okay, well, I'm going to break this down into the I root 15 all over 6. Well, okay, now that I get to the solution right here, what do I notice about the I? Remember, the I is imaginary. If it's imaginary, that means that it's not real. So if that's not real, then what do I know about these two equations? Oh, the x's are not real, so in this case, this graph is going to have no solution. The reason it's no solution is because the place that they intersect is imaginary. It doesn't exist. Okay, if we wanted to check it, we could go into Desmos and we could graph it. So let's go ahead and let's pause and let's look at what the graphs of those look like. All right, so we're back. Let's look at, I typed these two in straight into Desmos, just like what you can do, and went ahead and looked at the graph, and sure enough, those graphs, there's nowhere that they intersect. So in this case, our answer would be, if you go ahead, it would be okay to put no solution. So that is, let's look at a couple more of these. I'll do them rather quickly, and then I'll let you guys go ahead and get some time to practice. So we're going to solve the system using any method. So we've got, I look at which method would be best here. Well, in this case, I think that my best method would be by substitution. Okay, so I'm going to use substitution to go ahead and solve this equation. I'm gonna let negative 4x plus 8, and I'm going to plug it in for y up above here. So negative 4x plus 8 equals negative x squared plus 4. Okay, now remember, I got to get everything to the same side. So negative x squared, I'm going to actually add over x squared on this one, because I don't like it when x squared is negative like that. My a term is negative. So I'm going to make it positive. So I'm going to add x squared. I'm going to subtract 4. So I get x, positive x squared, minus 4x, subtract 4 over here. So I get plus 4 equals 0. All right, perfect. Now I'm going to go ahead, I'm going to look, can I factor this? Yep, oh, it's a perfect square. X minus 2 squared equals 0. So I end up with x equals, so square root of both sides, square root of both sides, x minus 2 x minus 2 equals 0. So I add the 2 over, x equals positive 2. In this case, there's only one solution. Now, is this my answer? No, remember we're looking for an ordered pair, so that means that x is 2. I've got to go ahead and find what my y value is. Well, I'm going to go ahead and I'm going to plug it into the equation y equals negative 4x plus 8. So y equals negative 4 times 2 plus 8. So y equals negative 8 plus 8. So y equals 0. So I get my point, the place at the intersect is 2, 0. In this case, my solution is only one solution. All right, let's go ahead and let's talk about these other ones. I see right away that on 2, I could use either elimination, if that makes sense to you, because the y's are kind of lined up right here. All I'd have to do would be to multiply this value here by negative 1, and make everything negative. That makes my y's cancel. Or I could use substitution. So that means that I could go ahead and I could subtract the 2x over and subtract the x squared, subtract the 3x, and get y by itself on both sides. Either way would work. It's up to you which method you would choose. So either of these, from this point, it doesn't really matter. The main thing is we've got to get it to be one equation. So let's look here. What I'm going to do is I'm going to use substitution on this next one. So I've got y equals negative 2x plus 5. Okay, so all I did was I just subtracted the 2 over. So I'm going to get rid of this negative 1. I'm not doing that method right now. There we go. Y equals negative 2x plus 5. All right. Now, I guess instead of having to if I were to move the x squared over, I'd end up with a negative x squared. And I don't really like working with a negative a value. So what I'm going to do is I am just going to take, because I've got this y all by itself rather easily, I'm going to take this negative 2x squared, and I'm going to go ahead and I'm going to plug it in just for that y right there. So x squared plus 3x plus, now I've replaced that y with negative 2x plus 5 equals 0. Well, all right, now since there's no minus, there's nothing to distribute inside, I can go ahead and forget the parentheses, combine like terms. So x squared plus x, 3 and negative 2 go together, plus 5 equals 0. Okay, so now that I set it up, I'll let you go ahead and you guys can finish that problem by yourself. This example is also worked out in your book. If you look at I believe it's page 133. At the very bottom of the page, there's a thing called monitoring progress. I'll let you guys see. Here in my book, it says monitoring progress. If you go to your online book, or if you go to the book that you download the app, off to the side right here, when you go to the app, there will be a little play button. So if you hit the play button, it'll have the worked out examples. Okay, this last one over here, number 3. Okay, that example is also in the book, and it is also worked out exactly for that solution. So you guys can go and check that if you want to work that example out. Okay, so let's go ahead and let's work. I'm going to go ahead and give you guys the homework assignment.